Hey class, Miss Akula here. We're looking at domain and range. So I'm on page 4 in our packets. So for this graph right here, I already did it, but it says to find the domain. So we're going to look on the x-axis, and basically what you're looking for is what is your starting point on the x-axis and then your stopping point on the x-axis. Well, it looks like it's starting at negative infinity because it's going to the left, and then it's stopping at positive infinity. We can express that in interval notation, the starting point and the stopping point. So starting at negative infinity, comma, and then the stopping point is positive infinity. And infinity is always open. When you have something like this, in set notation, we say all real numbers. Okay, so that's that. Over here, when I have this graph, I look at the leftmost point, which is at negative infinity, and then as there's a negative infinity, I'm at negative 3, and then it's stopping at positive 3 right there. Now, x equals negative 3 is technically this whole line right here. So since it's touching that at x equals negative 3, you put a closed bracket, and then it's touching it here at positive 3, and so you put a closed bracket as well. And then when we're writing it in set notation, we want to put it in using this form, which I'm going to show you right now. So it's going from negative infinity is less than or equal to x, and then you're going to do another less than or equal to, and then 3. So this tells me that x is between the negative 3 and positive 3. Whereas this one, I mean, I guess you can write it like this. You could say, sorry, it has like a little tip on it. But anyway, you can say negative infinity x to positive infinity, not equal to, just less than. You could say that, I guess, but instead of saying it this way, we prefer saying it all real numbers. Okay? Alright, let's look at the interval notation here. So the starting point on the x-axis, it looks like it's at negative 1. Okay? Negative 1. And the stopping point, well, it keeps going to the right, which is positive infinity. Okay? It's actually touching it at x equals negative 1, so I'm going to put an open bracket, and then I'm going to close bracket, and I'm going to put an open bracket here to show that, well, infinity is always open. And then over here, instead of writing it going from negative infinity less than or equal to x less than positive infinity, the two numbers, I'm going to write it a little better, and it looks like this. We can just say that x is greater than or equal to negative 1. This is how we write it in set notation. So you can pick any number greater than negative 1, and then it'll be in my domain. Alright, a couple more examples here. So let's go ahead and do this one. We want to see where the graph starts at. It actually doesn't really start at negative 5 because of the arrow. It means that it keeps moving to the left, right? So it actually keeps moving from negative infinity. So that's my starting number. And then it goes all the way to positive infinity. So anytime you have a graph that opens like this, or it can go up or down, it's always going to be all real numbers from negative infinity to positive infinity. And then so in set notation, we're just going to say x is an element of all real numbers. I don't know why, but I love writing all real numbers. This little symbol right here. Anyway, right here, for number 5, you have this line right here. If I look, the starting number is 2 and the stopping number is 2. Like, it's just 2. So we in interval notation, the starting number is 2, the stopping number is 2, so we're just going to do that. But we can also, for set notation, we're just going to say x equals 2, and that's it. Weird, huh? Alright, this one right here, you have the starting number on the x-axis looks like -2. The stopping number, the endpoint is at 1, 2, 3, 4, 5. So if you notice at -2, it's a closed circle, so I'm going to put a closed bracket. And then here it's an open circle, so I'm going to put an open bracket right there. And then in set notation, so it's between -2 and 5. But at -2, it's closed, so I'm going to put an equal to sign there and then leave it open at 5. And that's that. Okay. All right, let me move on to the, let me do this one, number 7. It says that the domain of this function is, well, let's see. It doesn't have an arrow, so that means it's not keep going to -infinity. So it's actually just starting at -1. So it's starting from -1. I'm going to write it here in interval notation. And it's going off. It's going up, but notice it's also going to the right. So it's actually going to positive infinity. So it's from -1 to positive infinity. And so what that means is everything greater than -1. So that's a domain right there. I was thinking maybe I should do a different video for range. Maybe I'll just continue. I'm on a roll here, so let me just continue. Alright, you guys, so on the next page here, on page 5, we have the range. So now I want you to like switch your mind. We were looking at it on the x-axis. Now we're going to look at the y-axis, going from -infinity to positive infinity. So we're going from bottom to top. So when I look at this, for the domain, if you remember, it was all real numbers. It was going to all the way to the left, all the way to the right. But I can't say that for number 8 here because it's not. It's not going all the way down, so it's not all real numbers. So let's see. It's starting on the y-axis at -2. And then it's moving up to positive infinity. So it looks like my starting point on the y-axis, so the lowest point is at -2. And then my highest point is positive infinity. So close bracket and then open. So for set notation, instead of saying this, this is not wrong. We're going to say y because we're talking about the range. This is not wrong, but it's a better way to say this. We're going to say that y is greater than or equal to -2. This is a better way to say it. So that's it. Okay. Let's go to the next page, next problem. So for the range, it's from -3 to +3, and it's included. So we're going to, in set notation, we're going to say y is from -3 to +3. And notice I put y because we're talking about the range, okay? So it's from -3 to +3. And then look at this range right here. It's not really starting here. It's because of the arrow, it means that it's actually going all the way down from -infinity and then going all the way up to positive infinity. So guess what? That's all real numbers. So it's from -infinity to positive infinity, open brackets. We're going to say y is an element of all real numbers. I personally think this is really cool. Number 11. I remember for the domain for this, we said all real numbers, but for the range for this, it doesn't go all the way to the top. It doesn't. So what we're going to say is, well, it's starting from -infinity because y is negative in the bottom, and it's going all the way up to 1, 2, 3, 4, 5. Y is 5. So these are my two numbers. It's going from negative infinity until 5. Infinity is open and 5 is closed because it's actually touching it at y equals 5. And then instead, again, it's not wrong if I say from negative infinity, okay, but we just don't write it like that. We think we're like, there's a much better way to write this. We're going to say y is less than or equal to 5. A couple more examples, guys. So for here, again, we're looking at the range. So for the range, it's going all the way down and all the way up. Definitely all real numbers, right? So we can say y is an element of all real numbers. I'm so happy to be able to write that again. Anyway, interval notation is from negative infinity to positive infinity, and that's that. All right. For this one, the lowest number, it looks like it's at negative 2, with a hole at negative 2, and positive infinity. So I'm going to say that it's from negative 2 until, did I say, I don't know why I keep saying positive infinity, but I meant positive 1. And then at negative 2, there's an open circle, so it doesn't include it. It says not touching it right there. So we're going to put an open circle, open parentheses there. And then at 1, we're going to put a closed bracket. Okay? And then for set notation, we're going to say, so y is between negative 2 and 1. But not including negative 2, but including 1. Let me look at it again. Yep, it looks good. All right, last question, y'all. So it looks like it's starting from negative infinity to, on the y-axis, it's at 0. So, which means that y is less than or equal to 0. This one right here. There you go, guys. I have a worksheet somewhere. I wanted to do some SOL review for these type of questions. Let me find it. If I don't find it, then I'll just end the video here. I can't find it. All right, guys. Thank you, and yeah, thanks for watching.